ಸರ್ ಇವತ್ತು ಬುಧವಾರ ಕ್ಲಾಸ್ ನಾನು ಬುಧವಾರ ಕ್ಲಾಸ್ request
Morning. रमेशन्ना भाभी जी ने क्या खिलाया आज? अच्छा
हेलो सर
ವೇವ್ ಬೋರ್ಡ್ ಆಡೋದು ಕಲ್ತ್ಬಿಟ್ಟಾನೆ. ಓ ಅಯ್ಯೋ ಹೇಳ್ತಾ ಬನ್ನಿ ಮಗ.
ಯಾವ ಗೇಮ್?
ವೇವ್ ಬೋರ್ಡ್ ಎರಡು ಗಾಳಿ ಆಗ್ತೀನಿ
सर सर
ಹಾ
सर ಇವಾಗ 9:30 ಕ್ಲಾಸ್ ಇದೆ ಸರ್. ಮಾಮ್ ಕ್ಲಾಸ್ ಇದೆ ಅಂತ ಹಾಕಿದ್ದಾರೆ 9:30.
ಇಲ್ಲ ಇಲ್ಲ ನನ್ನ ಕ್ಲಾಸ್ 9:30ಗೆ ಆಸ್ ಪರ್ ದಿ ಟೈಮ್ ಟೇಬಲ್.
ಹಾ ಓಕೆ ಸರ್ ಓಕೆ.
ಕಂಟಿನ್ಯೂ ಮಾಡ್ಕೊಳ್ಳಿ. ಹಾ
ಇಲ್ಲ ಸರ್ ಓಕೆ ಮಾಡಿ ಸರ್.
ಹಾ ಅವ್ರು ನನಗೆ ಟೈಮ್ ಟೇಬಲ್ ಕೊಟ್ಟಿಯಾರಲ್ಲ ಅದರಲ್ಲಿ ಕರೆಕ್ಟ್. ನಂದು 9:30 ನನ್ನ ಕ್ಲಾಸ್.
ಹೌದಾ ಸರ್? ಇಲ್ಲ ಸರ್ ಗ್ರೂಪಿಗೆ ಮೆಸೇಜ್ ಬಂತು ಅದಕ್ಕೆ ಹೇಳಿದೆ ಸರ್ ಅಷ್ಟೇ.
ಯಾರು ಅವ್ರ ಗ್ರೂಪಿಗೆ ಮೆಸೇಜ್ ಹಾಕಿದ್ರಾ?
ಅಲ್ಲ ಸರ್ 9:45 ಮಾಮ್ ಕ್ಲಾಸ್ ಇದೆ ಜಾಯ್ನ್ ಆಗಿ ಅಂತ ಮೆಸೇಜ್ ಬಂದಿತ್ತು.
ಇಲ್ಲಮ್ಮ ಇಲ್ಲ ಚೇಂಜ್ ಆಗಿದೆ ಟೈಮ್ ಟೇಬಲ್ ಅದು.
ಹೌದಾ ಸರ್? ಓಕೆ ಸರ್ ಆಯ್ತು ಸರ್.
ಹೌದು ಎಲ್ಲ ಚೇಂಜ್ ಆಗಿದಾವ.
ಹೌದಾ ಸರ್ ಆಯ್ತು ಸರ್ ಓಕೆ.
ಆಮೇಲೆ ಪವನ್ ಇನ್ನು ಇವತ್ತು ಮತ್ತೆ ಬುಧವಾರ ಕ್ಲಾಸ್ ತಗೊಂತೀನಿ. ಪೋರ್ಷನ್ ಮುಗಿದೋಗ್ಬಿಡುತ್ತೆ ನಂದು.
ಹೌದಾ ಸರ್? ಓಕೆ ಸರ್.
ಹಾ
ಸರ್ ನಿಮ್ಮ ಆಫೀಸ್ ರೂಮಿಗೆ ಬರ್ತೀನಿ. ಇದು ನೋಟ್ಸ್ ಇಂದ ಹಾರ್ಡ್ ಕಾಪಿ ಕೊಡ್ತೀರಾ ಸರ್? ಜೆರಾಕ್ಸ್ ಮಾಡಿಸ್ಕೊಡ್ತೀನಿ.
ಕೊಡ್ತೀನಿ ಕಣ. ಅಲ್ಲ ಹಾರ್ಡ್ ಕಾಪಿಗಿಂತನ ಇದು ದಳವಾಯಿ ಕೊಡ್ತೀನಿ. ಜೆರಾಕ್ಸ್ ಬರ್ಕೊಂತೀಯಾ?
ಸರ್ ನಂದು ಹಾಸ್ಟೆಲ್ ಸರ್ ಅದು ಎಲ್ಲಿದೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ ಅದಕ್ಕೆ ಇಲ್ಲೇ.
ಇವತ್ತು ಮತ್ತೆ ಹಾಕ್ತೀನಿ, ಫುಲ್ ನೋಟ್ಸ್ ಹಾಕ್ಬಿಡ್ತೀನಿ ಇವತ್ತು.
ಅಲ್ಲ ಸರ್,
ಹಲೋ
ಸರ್ ನಂದು ಇಲ್ಲಿ ಹಾಸ್ಟೆಲ್ ಇದ್ದೀನಿ,
ಹಾ
ಅದು ನನಗೆ ಎಲ್ಲಿದೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ ಸರ್, ದಳವಾಯಿ ಇದು, ಅದಕ್ಕೆ.
ಹೇಳ್ಕೊಡ್ತೀನಿ ಬಾಮ್ಮ. ಎಲ್ಲಿ ಗೊತ್ತಾ, ಕಾನ್ವೆಂಟ್ ಡಿವೈ ಸರ್ಕಲ್ ನೋಡಿದ್ಯಾ?
ಇಲ್ಲ ಸರ್, ಗೊತ್ತಿಲ್ಲ.
ಹೌದಾ, ಯಾರ ನಮ್ ಫ್ರೆಂಡ್ಸಿಗೆ ಕೇಳು, ಅವ್ರಿಗೆ ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಅಲ್ಲೇ
ಹಾ.
ಜೆರಾಕ್ಸ್ ತಕೊಂಡ್ಬಿಡು.
ಓಕೆ ಸರ್, ಆಯ್ತು ಸರ್.
ಹಾ ಹಾ
ಓಕೆ ಸರ್, ಆಯ್ತು.
ಬೇಕಾದ್ರೆ ನೀವು ಫೋನ್ ಮಾಡಿ ಹಿಂಗೆ ನೋಟ್ಸ್ ಜೆರಾಕ್ಸ್ ಮಾಡಿ ಇಟ್ಟಿರಿ, ನಾನು ಬರ್ತೀನಿ ಅಂತ ಹೇಳಿ ಯಾರು ಫ್ರೆಂಡ್ಸ್ ಕಳಿಸು, ಆ ಕಡೆ ಹೋಗೋರಿಗೆ ಕೊಟ್ಟು ಕಳಿಸ್ತಾರೆ ಅವ್ರು.
ಹೇಳ್ತೀನಿ ತಗೊಳ್ಳಿ ಸರ್ ಅವರಿಗೆ.
ನೆನ್ನೆ ಹೇಳ್ ಬಂದಿದ್ದೀನಿ ನಾನು, ಫುಲ್ ನೋಟ್ಸ್ ಹಾಕ್ತಾ ಇದೀನಿ ಇವತ್ತು ಅಂತ.
ಓಕೆ ಸರ್, ಆಯ್ತು ಸರ್.
ಹಾ
ಓಕೆ ಸರ್.
See, this is the last portion in module 5, that is strain measurement. Strain measurement. Have you seen the fuel tank of the two-wheeler, or fuel tank of four-wheeler, or fuel tank of truck? You can directly see the position of the fuel in the tank in the dashboard. How do you measure the position of tank, or how much fuel is present in the tank? For that, they use electrical resistance strain gauges. Electrical resistance strain gauges. So in the tank, they fix the electrical resistance strain gauges like this. All of you observe here. This is electrical resistance strain gauge. So they fix this type of strain gauges in the tank at 1/4 level, half level, 3/4, and full level. And then this is works on piezoelectric phenomena. This works on piezoelectric phenomena. You have R equal to rho L by A. If you provide electric current in the circuit, the fuel exerts the pressure on the strain gauge, so that there will be change in the resistance. That is R equal to rho L by A. R equal to rho L by A. That is the particular electrical resistance strain gauge works on works on piezoelectric concept. Piezoelectric concept. See, first you study the definition of strain. Strain is the difference between the final dimension to the initial dimension divided by initial, and is epsilon A, that is axial strain. That is the ratio of difference in the final length to the initial length to the initial length. The change in initial length to the final length called epsilon A. Next, come to the point. This is the electrical resistance strain gauge, works on piezoelectric effect, and this is placed assembling of electrical resistance strain gauge. This is thin phenolic paper. They use two thin phenolic paper. Then this is the wire grid, which is made from silver alloy or copper alloy, which is connected to the leads. All of you observe it. Copper wire connected to the leads. Usually, the strain gauges are connected in Wheatstone bridge. All of you already studied a Wheatstone bridge. Wheatstone bridge circuit. So this is the assembling of electrical resistance strain gauge. All of you observe here. This is the electrical resistance strain gauge. This portion, all of you observe here, looks like a spring. This is called wire grid. This wire grid is sandwiched between two thin phenolic paper, upper one, lower one, or bottom and the top, placed inside the two thin phenolic paper by using phenolic resin. And after the leads are connected to copper wire. Usually, the wire grid is made from copper alloy or silver alloy. All of you observe here in Maruti 800 car, Maruti Brezza, Maruti's Desire, shift in all the cars in the fuel tank, inside the fuel tank. They fix the strain gauges like this due to the pressure exerted by the fuel on the strain gauge. That is that changes the electrical characteristic of the strain gauge. That is the change in the this resistance, change in the electrical resistance rate by using the relation R equal to rho L by A. Rho L by A. Rho is the resistivity of the material, that is ohm centimeter. All of you observe rho is the resistivity of the material. That is the wire that is made from silver alloy or copper alloy. The section of the wire is maybe circular or square. If is circular, the diameter d may be considered. If it is square, the length, side of the length, cube length is considered. And L, rho L, L is the length of the wire or length of the conductor in centimeter. Rho L by A. A is the area of cross section of the conductor, that is in centimeter square. Or resistance, that is the resistance is in ohms, that is in resistance in ohms. The piezoelectric concept that works on piezoelectric concept, you have to use the principle R equal to rho A. All of you, please write down the
Audible.
write down the question.
Hello. Hello.
What is strain
Am I
measurement?
audible? ಮಂಜುನಾಥ ಹೇಳ್ತಾ ಇದೆಯಪ್ಪ ಮಾತಾಡೋದು.
What is strain measurement?
ಹರ್ಷವರ್ಧನ್, am I audible?
Put a question mark.
Hello.
Next line write down. Next line write down. Derive an expression. Derive an expression for electrical resistance strain gauge with suitable sketch. With suitable sketch.
Hello.
Of you.
Hello.
Very important. Almost all the question papers you have this question in the exam.
Hello. Hello. Hello.
You have this question
Hello.
in the examination.
Hello. 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 Any disturbance? Bracket? Am I audible? Persistent, any disturbance? Hello? Hello? Am I audible? Okay, we'll start with pick up a new tab.
The derivation is based on differentiation of equation R equal to rho L by A. So where rho is the specific resistivity, L is the length of the conductor, A is the area of the conductor, R is the resistance. On differentiation with respect to with respect to the resistance on differentiation, All of you observe here. See, R equal to rho L by A. Rho is the resistivity of the material. L is the length of the conductor. A is the area of cross section of the conductor. All of you observe here. A equal to CD square. A equal to CD square. C is constant depending on material. D is the dimension of conductor. If A equal to CD, C is a constant. Its value is 1 for square cross section, and D is the pi by 4 for circular cross section. Cross section. So on differentiation, R equal to rho L by A, dr by R, d rho by rho plus dl by L minus 2d d by. So on definition of axial strain, on defining a change in the initial length to the final length, that is epsilon A, that's called axial strain. And difference in diameter of the conductor, initial diameter to the final diameter, that is the ratio of initial diameter to final diameter. This is epsilon L. This is called lateral strain. The negative unit of lateral strain to the axial strain, that is the diameter to the length, that's called Poisson's ratio. Poisson's ratio. All of you observe. This is very, very important. All of you observe here. dl by L equal to epsilon A, axial strain, and difference in the diameter, initial diameter to the final diameter. That is the ratio of initial diameter to the final diameter. That is the strained diameter epsilon L, which is called lateral strain. And the difference between the diameter to the length is called Poisson's ratio. Poisson's ratio. So this is the derivation required for electrical resistance strain gauge for measurement of strain. Next, come to the equation may be expressed in terms of substitute that value in the equation dr by r. The above equation may be expressed as resistance to the change in length. When you apply the load on the grid or strain gauge, there will be change in the resistance because of change in the length. That is the ratio of change in the resistance to the length, which is equal to plus 2 mu. That is the equation for definition. All of you observe here. So substitute the values of d rho by rho, dl by L minus 2d by d. So that is the value of d rho by rho is 1 plus the value of change in length to initial length is 2 mu. That is the Poisson's ratio plus the resistivity to the change of length, which is equal to gauge factor. You are all belongs to mechanical engineering. Remember the word gauge factor. Change in resistance to the change ratio of change in resistance to the change in length is called gauge factor. That is R dr by R equal to GF into axial strain change in length. Gauge factor. This is very, very important for mechanical engineers. Gauge factor or change in initial resistance to the final resistance is called gauge factor into epsilon A. Term change ratio of change in resistance to the change in length is called gauge factor. Remember, this is a very, very important for mechanical engineers. Gauge factor. Almost all the competitive examination, you have a question on gauge factor. That is the change in resistance. The change in resistance to ratio of change in resistance to the change in length of the conductor is called gauge factor. GF. The specific resistivity does not depend on strain. See, the resistance of the material, that's called material, does not depend on strain. Then gauge factor equal to 1 plus 2 mu. See, all of you observe here, specific resistivity or the value of strain does not depend on the material of the conductor. So then GF equal to 1 plus 2 mu. The Poisson's ratio for all the metal, remember all of you, in The Poisson's ratio for all the metal is 0.3. Then substitute this value in this gauge factor equation. You will get gauge factor equal to plus 2 into 0.3 equal to 0.6. You have to study the gauge factor, derivation of gauge factor from the relationship or equal to rho L by A. Rho L by A. Rho is the resistivity, L is the length of the conductor, A is the area of cross section of the conductor. So the derivation you have to derive in the examination. Second, start from the metallic electrical resistance strain gauge. All of you observe here. This is the strain gauge used in almost all the mobiles for measurement of fuel in the fuel tank. That indicates um, off position, one four position, full position, three four position. Position of the fuel in the fuel tank. They fix the electrical resistance in the position of 4, half, 3, 4, and full. When the fuel pressure on the fuel, pressure on the strain gauge, there will be change in the resistance. See, how do you assemble the electrical strain gauge? You have a question on this installation factors for electrical resistance strain gauge. First, observe here brown color paper. It is called phenolic resin paper. Keep the wire grid made of copper or aluminum alloy or silver alloy, which is placed in between the two paper. That you can define like this. The wire grid along with the lead is sandwiched between two thin phenolic paper. Phenolic paper may be water resistant, electrical resistance, and a non-conductor of heat. For that reason, thin phenolic paper is used for fixing of strain gauge in between two strain gauges. After assembling, strain gauge look like this when the leads are coming out, which are soldered by using copper alloy wire. After assembling, you can fix this on the measurement of axial strain, bending strain, and the torsional strain. Next class, we will discuss the measurement of axial strain, measurement of bending strain, measurement of torsional strain. In all the three cases, how to fix the strain gauges on the specimen or on the member. So it is very, very important and derive an expression for electrical resistance strain gauge. Please write down the question, derive an expression, derive an expression, derive an expression for electrical resistance strain gauge. Derive an expression for electrical resistance strain gauge suitable sketch. With the suitable sketch. For this question, you have to write the diagram. All of you observe here. All of you write the diagram like this. This is the simple diagram. Keep the wire grid in between two thin phenolic paper and fix this by using the suitable gum or adhesive or phenolic cement. So fix the grid in between two paper and connect this to the lead, which is connected to the copper wire. After assembling, strain gauge look like this. All of you observe here. This lead is connected to the copper. So usually this is used in vehicles, two-wheeler, four-wheeler, truck, and all the vehicles to study the to know the how much fuel is present in the fuel tank. Next, come to the point, the very, very important examination point of view. Almost all the question paper, you have a question on derive an expression for electrical resistance strain gauge. Electrical resistance strain R equal to rho L by A. Rho is the resistivity of the material, that is in ohm centimeter. L is the length of the conductor, that's in centimeters. Centimeters. Area A is the area of cross section of the conductor, that is in centimeters square. Then R equal to resistance in ohms. When you want to derive an expression for electrical resistance, you have to differentiate the equation R equal to rho L by A. On differentiation, you will get, so before that you study the area of A equal to CD square. C is the constant, D is the dimension of the conductor. D on C is a constant, its value 1 for square cross section of dimension D and pi by 5 for if it is circular cross section of diameter D. So the dimension D is if the square cross section, that is the length in centimeter, or otherwise if it is circular, that is the diameter D. So on differentiation, dr by r equal to d rho by rho plus dl by l minus dd by d. So that is the change in initial length to the final length, or ratio of initial length to the final length is called A. That is axial strain. And next, the ratio of initial diameter to the final diameter, or ratio of change in diameter to the initial diameter, is called lateral strain, epsilon L. Epsilon L, lateral strain. And the ratio of change in diameter to the change in length of the conductor is called Poisson's ratio, indicated by mu, indicated by mu. This is very, very important. All of you observe here, if you differentiate the equation piezoelectric effect R equal to rho L by A, you will get the equation dr by R equal to d rho by rho plus dl by L minus 2dd by d. That's the change in length, or ratio of change in length to the final length, or ratio of initial length to the final length is called del strain, and the change in initial diameter to the final diameter, or ratio of initial diameter to the final diameter is called lateral strain. If the relation change in diameter, ratio of change in diameter to the change in length is called Poisson's ratio. This mu. Then substitute the value of equation, this equation, then you will get dr by r divided by dl by l equal to 1 plus 2 mu plus d rho by rho divided by dl by l equal age factor. See, remember the expression for age factor is defined as ratio of change in resistance to the change in length. All of you remember the ratio of the change in resistance to the change in length. That is the dr by r divided by dl by l. You can define like this: the ratio of change in resistance to the change in length is called gauge factor. If you apply the load on the strain gauge, then there will be change in the resistance, that you can do. 1 plus 2 mu plus d rho by rho divided by dl by l equal to df. Or simple equation, change in resistance, initial resistance to the final resistance equal to gauge factor into axial strain, epsilon A. Then, very, very important, the term, the change in initial resistance to the final resistance, change in resistance, dr by r divided by dl by l, the same equation is called gauge factor. gauge factor is called, once again, this is also, it is called as axial sensitivity or gauge factor. Then up to this only, this is for derivation of gauge factor. And you have to substitute the value of mu in the equation. That is gauge factor equal to 1 plus 2 mu. The Poisson's ratio for all the metal, remember, all the metal which are available is 0.3. 0.3. Substitute the value of 0.3 in this value, in this equation. Gauge factor equal to 1 plus 2 into 0.3. Jf equal to 1 plus 2 into 0.3 equal to 1.6. This is gauge factor. This is gauge factor for all the calculation of a strain. If you use the electrical resistance strain gauge, then the gauge factor is 1.6. 1.6. This is very, very important. All of you, please write down the question. Derive an expression for electrical resistance strain gauge with suitable sketch. With suitable sketch. Please, all of you, mark it very, very important. You can expect this question time. You can expect this question this time. Now I stop at this stage, and all of you, please write your all of you, please write your name and USN in the thought box. I stop at this stage, and Wednesday I will continue, and I will complete the module 5 on Wednesday. Answer roll call. All of you, please unmute yourself. Answer roll call. Please write your name and USN the chat box. Panilekan, write your name. Pritam D, write your name.
Sir. Present, sir.
Yes, yes.